Good morning and welcome back for the second part of 7.3. So this part doesn't totally have a relationship to, it does have a little bit of a relationship to the quadratic equation in some forms, but it really is more about taking solutions like x-intercepts and finding them back into creating the original equation. So I'm going to show you, for instance, let's say we had the equation x squared minus 6x plus 5. Okay, and I set it equal to 0, and I wanted to find the x-intercepts. I could factor this into x minus 5, x minus 1 equals 0. Notice that there are two binomials. I can then set them each individually equal to 0. And when I do, I can do that because either of these things, if either of these items equals 0, either of these binomials equal to 0, one of them being 0 will make the other one multiply to equal 0, which is our goal. And so I'm going to see if I make this x minus 5 equal to 0, I can add 5 to both sides and I get x equals 5. And over here, I can add 1 to both sides and I get x equals 1. So that means if I put 5 into this first binomial, I will have 5 minus 5 times, 5 minus 1 equals 0. And 5 minus 5 is 0 times 4 equals 0. And yes, 0 equals 0. And I can likewise do the same thing over here. So now what we're doing in 7.3 is we're saying, what if I start with the solutions? Or rather, we call them the x-intercepts. That's really what we're starting with. What was the original equation? That's what I want to do. I want to work backwards. So I want to start with these, this x equals 5 and x equals 1, and work backwards. So let's say I gave you question number 23 in the book, and I said, here are my solutions, x equals 5 and x equals 2. And as an x-intercept, that would look like this, the 0.5 comma 0 and the 0.2 comma 0. Okay. So that means on our graph, we would have 2 comma 0 and 5 comma 0. That would be this one and that would be this one. And now we could have a parabola that faces up and goes through those 2 points, or we could have a parabola that faces down and goes through those 2 points. Either of those works, but the base one is going to be found by, we have x equal 5 and x equal 2. We're going to get the 5, we're going to get everything to one side by subtracting 5. We get x minus 5 on the left equals 0. So you want to move everything over so it equals 0. The same thing over here. We get x minus 2 equals 0. So now we know that x minus 5 and x minus 2 are the two binomials. So my equation, my function f of x is going to equal x minus 5 times x minus 2. So I'm working backwards from what I did up here. And then I'm going to use my FOIL to multiply these together. So I get x squared minus 5x minus 2x plus 10. And then I have like terms in the middle. So I end up with x squared minus 7x plus 10 is my function f of x. And this one happens to be face up. So it would have been this one here. Okay, and we can tell because we're going to learn about it in 7.5. I don't want to tell you how we know, but you can graph this in Desmos and see that. So let's try another one. Let's say we look at number 25. So 25 in the book gives us those solutions, the solutions. T equals a -3 and T equals 6. And so these would be the x-intercepts of -3, 0, and 6, 0. That's what that would look like. And so by getting them to the other side, we're going to add 3 to both sides. So we have T plus 3 equals 0. And over here, we're going to subtract 6. So we'll have T minus 6 equals 0. And that means our function of T is going to be those two things multiplied together, T plus 3, T minus 6. And then again, we're going to FOIL these just like we did before. So T squared plus 3T minus 6T minus 18. And we always have the 2 in the middle that are like terms. So T squared minus 3T minus 18 is my function. And this would go through the point a -3, 0, and then 6, 0. And it's going to be, if you put this into Desmos, it's going to be face up, something like this. Okay. So let's try one. Let's try 29. So 29 has the solution x equals 1/2 and x equals 3. Okay, so you might think of this as just let's subtract 1/2 from both sides, but we really want to do this in 2 steps. So we want to multiply by the denominator. So let's just write that. Multiply by the denominator first. So that's going to be multiplying both sides by 2. So the 2 cancels on the right, which is what we want. We have 2x equals 1. And then we're going to move the constant over. Then add or subtract to move constant over. So we end up with 2x minus 1 equals 0. So if we were to solve for x, we would add 1 to both sides and divide by 2. So we would end up with the 1/2, but we don't want this to be a 1/2 of 0.5. We want it to look like this so that we can multiply our binomials. And then over here, we're going to subtract 3. So we get x minus 3 equals 0. So now our function of x is really 2x minus 1 times x minus 3. And we can multiply our binomials together. So we get 2x squared minus x minus 6x, because remember we have to multiply each of these, the inside, outsides, first and last. And then we get plus 3. So combining our like terms, we have 2x squared minus 7x plus 3 is our function. So our x-intercepts would indeed, they would be at 1/2. So 1/2 and 0 and 3 and 0. But the way we build our function is we have to multiply both sides by that denominator and then move the 1 over. So we're going to get practice doing another one. Let's look at number 35. 35. So 35 says A equals a -1/2 B, oh, and the other A equals, sorry, 3/5. Okay. So again, we're going to multiply by the denominator. So we get 2A equals a -1. And then we're going to add 1 to move the 1 to the other side. So it's 2A plus 1 equals 0. And then likewise over here, we're going to multiply by this denominator. So it cancels 5A. So we end up with 5A equals 3. And then we have to move the 3 to the other side by subtracting 3. So we have 5A minus 3 equals 0. Then we can set up our function is going to be 2A plus 1 times 5A minus 3. So when we do our FOIL multiplication, 2A times 5A is 10A squared. 2A times a minus 3 is a minus 6A. 1 times 5A is just 5A. And then 1 times a -3 is a -3. Combining our like terms, we get 10A squared minus A minus 3 is our function. And it would actually equal 0. Each of these would actually equal 0 because that's what our goal was to get to 0. Okay, I'm going to show you a couple that are not just in a quadratic because they actually have 3 solutions. So this equation is not a quadratic. These are not quadratics because they have more than 2 solutions. Okay, but they're fun. Once we put them into Desmos, I'll show you. Okay, so let's look at 27. 27 says it's an equation that has y equals 2 as a solution, y equals a -2 as a solution, and y equals 4 as a solution. So that means that this graph would actually have the y-intercept of the 2, 0, that one, the -2, 0, that one, and then 4, 0, that one. So if we put this on a graph, we would have 2, 0 here, and -2, 0 here, and 4, 0 here. So somehow it squiggles up and down. So we're going to see what that looks like. So let's get each of these set equal to 0. So subtracting 2, we get y minus 2 equals 0. Adding 2, we get y plus 2 equals 0. And subtracting 4, we get y minus 4 equals 0. Then to get our function of y, we're going to multiply each of these binomials together. So y minus 2y plus 2y minus 4. I do 2 at a time. It doesn't matter what 2. So I'm going to do these 2 first. Oh, and they're conjugates, so that's cool. So they work out to be a difference of squares. But so we multiply y squared plus 2y minus 2y minus 4. Don't forget times our minus y minus 4 over here. So let's simplify this. This is y squared. Those 2 cancel, so minus 4. And then we're going to multiply by y minus 4. So we're going to FOIL again. So that becomes y cubed minus 4y squared. This one is a minus 4y, and then a plus 16. So we don't have any like terms, but this is our equation. So let's put this into decimals so you can see what this graph looks like, because it should go through these 3 points. Let's just go to decimals to try it out. So we're going to put in, I'm using X instead of Y because remember decimals doesn't like other letters. It likes X as its input for X squared. So that's all I'm doing. Minus 4X plus 16. Oh, there it is. Look at that graph. How pretty is that? And indeed, when I click and hover over the points, there's a -2, 0, there's 2, 0, and there's 4, 0. How cool is that? Now, we actually could have originally just done this. Once we got our binomials, we could have just said parentheses x minus 2 times parentheses x plus 2 times parentheses x minus 4 parentheses, and we would have looked at it eventually formed the same exact graph. So you could have just put the binomials in right there to come up with those. So cool. I'm not going to do any imaginary ones because that's not what our goal was here. I think that's enough because you're going to get some imaginary numbers when we work in Desmos later in 151. So that should get you started on coming up with equations. Reach out if you have any other questions and catch me back for lesson 7.5.